ladies and gentlemen, I'd like to introduce our team and our project. We did the Tom and Jerry bots. So, let's introduce our team. First, we have Jonathan.
I'm Jonathan. I'm a mechanical engineering student. I'm a senior.
We have Weston.
Yep, I'm an electrical engineering student.
And my name is Brandon. I am a electrical engineering graduate student. So let's get into our bots. What we have is we have Tom and Jerry. Now, for a lot of people, you may or may not know where we got the names. The names came from a 1980s cartoon about a cat and mouse who pretty much tormented each other. The cat was always trying to eat the mouse was always tormenting the cat. So we decided we were going to make robots that did the same thing. Now, on to the inspiration for our project. So the thought behind the project originally was we wanted bots that would go and mimic the useless machine. And basically, it was, we wanted our bots to go over, flick the machine's toggle switch, and then the other machine would turn its switch off and go back and torment the other one. That was our original thought, was having self-seeking useless machines. Let's talk about our criteria for our bot. All right, so in our initial proposal, we said our bot was going to work within a 2.5 to 5 foot box. We said we would have 2 different colors, and that was because originally we were going to use chromatic sensors. We said that we would absolutely have ultrasonics, and that we were going to have a toggle switch and a linear actuator on our bots because that's what goes or matches the useless machine. We had to make some changeouts. Okay, so with these changeouts, what we had was we had our chromatic sensor. We found that once we got it and we got into the data sheet that it only sensed within 5 millimeters. Definitely not going to work with our 2.5 to 5 millimeter or 2.5 to 5 foot space. So we had to get rid of our chromatic sensors. Gone. Okay, how are we going to find each other? We decided to go with the IR. Golden has some other issues. We'll get into that later. Now, we were talking about our toggle switches and our stepper motor. As I said, we thought about it, but we bought the linear actuator. Linear actuator only had a, maybe a 2.5 millimeter stroke. Toggle switch has a longer stroke on the push and pull. So, linear actuator is not going to work. We went and looked for better linear actuators. The problem is the stroke on the linear actuators that we could get was about 5 to 8 inches and putting out so much force that it would damage our little Tom and Jerry here. So that's out of the question. So what did we go with? We went with push buttons. So this is our toggle switch here, and this is our linear actuator. This hits our button, which actually causes the switch. So we're out of toggle, but we have 2 push buttons. So I feel like we're still kind of within our criteria. We're still making the same things happen, just with a little bit different materials. Now, let's get into the coding part of this, because that was a monster. And for that, I'm gonna call Jonathan in because he is the man when it came to the code. Jonathan.
Okay, our main function for the cat, this is just going to loop indefinitely. So what happens is it'll turn right, and then it's going to check if it's receiving an IR signal. The way it does this is whenever the receiver receives input, it's going to trigger an interrupt, which is going to measure the length of the pulse. And while it is receiving this signal, the motors are going to move forward, and it's going to check if the distance is less than 5 millimeters, just to see if it's running into any objects. And then if it is less than 5 millimeters, if it's less than 5 millimeters, then the motors are going to reverse. And then it's going to do this indefinitely until it receives an interrupt from the plunger. And the plunger interrupt is going to reverse the motors, and then it's going to turn them off and change the state into a mouse state. The mouse state does is it just remains stationary until it receives an interrupt on this button, and that is going to cause a delay, and then it's going to cause the motors to move forward. It's going to execute this main function.
Thank you, Jonathan. Thank you so much for your time. Okay, so now what we're going to talk about is that we're going to talk about some of the testing and troubleshooting that we did. All right, so for the first thing that we tested was our motor and our motor control. So we used an H bridge for this, and so it had 6 pins that we used. So these both are the enable pins, and so these control the speed. And then the speed was determined by pulse width modulation, or PWM. And so then these pins are out pins, and then those are just determined by the H bridge. And so 1 and 3 determined a forward motion, and then 2 and 4 determined reverse motion. And so how we tested that is that we originally had 4 buttons wired up so that they would trigger interrupts, and if, you know, 1 for forward, 1 for each direction that we planned on, forward, right, left, and reverse. And if it moved according to its corresponding button, then we knew that it was successful. The next thing that we troubleshooted was our IR sensors. Originally, how we did it is that we just tried to do a continuous beam, but because of the way that the receiver is built, it'll only detect a pulse for so long. So all of this over here was being left undetected, and so it would only work for, you know, this amount of time. To combat this, what we did is instead of just making a continuous beam, what we did is that we did a pulse width modulation to our transmitter, and so it would send roughly 1,000 signals in like 10 milliseconds, and then we would pause or delay for that amount of time to make sure that there was no unforeseen errors or issues. When we got our bots with our housing units like they are now, what an error that we came into is that it would detect its own transmitter, because the transmitter will go out in a 45-degree angle, and since the transceiver is over here, it would detect the light bouncing off of other things, and so it would detect its own transceiver. So what we did is that we made it so that 1 was only active in the state. So the cat mode is only the transceiver. The receiver for the cat mode is the only thing that's activated. In mouse mode, the transmitter is the only thing that's activated. And so the reason why we had to have our target button area so large is because our bot would come on over here, it would detect, and so it would drive off to the side. So that's why we created a very large 3D printed object that's attached to our button, because this is the area where most concentrated amounts of hits were. For our ultrasonics, what we did is that we simply had the other bot being in front of it and see if it measured the distance properly, and if it did, that, you know, Tom here, for example, would back off to the accorded distance.
Thank you, Weston. All right, so here we are at the conclusion. So do they work? I'll let you decide in just a moment. You'll see them actually in action. So there's the proof. They work. Current issues. Obviously, our IR is still not aligning perfectly. Okay? There's things we can do to tweak that. If we had the wherewithal to find better sensors, or a little bit more money to afford a higher quality sensor for the alignment, we can get that fixed. The other issue that we're running into is our buttons. These buttons that we had that came out of our lab kit, just really weren't meant to take the amount of abuse that these bots are giving them. We've gone through probably 7 or 8 buttons just in our testing where the bots have just destroyed him by too many button presses. Other than that, this really was a great project for our team. We learned a whole lot. Thank you for watching. Have a good evening.